Right, howdy. Um, this is the intro video for the length of day investigation. Okay, so we're using a program called Stellarium, and this is the free website version of it, which is actually really cool. So if you have any interest in astronomy, this is a neat website, Stellarium. If you just type it into Google, Stellarium, it'll pop up. All right. But it's usually used for identifying constellations and stuff like that, like what's out at night. We're going to use it to kind of keep track of the path of the sun on the 4th of July in 3 different locations around, the Americas. All right. So, a couple things I want to point out. We are going to talk about, how high the sun is above the horizon. So, it's a little confusing looking, but this is the horizon, right? So if we were outside looking north, at this particular time in this particular location, these are the stars that we'd see. We'd see these constellations right here, right? Some of you might remember some of those or find them familiar. All right. But we're not concerned about the constellations. That's just what I'm pointing out. So what I need you guys to understand is that the horizon here, it curves because obviously our field of view is a circle, all right? The horizon feels circular and the sky itself feels like a dome, right? Like a portion of a sphere, because of course our atmosphere is a sphere, right? So I want you guys to understand that, the closer we look towards the center here, the higher up it is. So when you're looking in the direct center of this part of the sky, like right here, that means you're looking straight up, right? And everything in between is going to be between 0 and 90 degrees, right? Because straight up is a 90-degree angle, right? Everything between the horizon and directly above you is between 0 and 90 degrees, okay? We don't need to get too specific. We're going to try to recreate this in our length of day investigation worksheet here. So this is the worksheet that you're going to have access to, right? And it's really hard for me to curve things, so you can't see the sky as a curve or the horizon as a curve, but we're going to look south. And when you look south, east is on the left and west is on the right. It feels backwards, but that's the case. And I know the sun rises in the east and it sets in the west, okay? What we are going to do is mark the approximate locations of the sun at various times of the day and compare them. Farmington Hills, Miami, Anchorage, Alaska. Okay. And we're going to place those, appropriately on our field of view. This is supposed to be similar to this, right? So here's us facing south. Okay. Now I'm going to change it to the 4th of July here. So I'm going to go, all right, I'm actually going to go like that. And then I'm going to increase it up to the 4th of July. Here we are. Okay. Now, this is the 4th of July at sunset. I know that because here's the sun over here. It's setting in the west, right? So that's sunset. So I actually want to go backwards in time so that we can see the sun rise. So I'm going to actually do this. I'm going to move over so I can see where the sun rises here, right? It looks to me like it's getting pretty close there. So I'm going to just go by minute. Okay, so there's roughly the exact time the sunset rises. Okay, it's the moment when the word sun pops up. So, there it disappeared. So I'm going to go minute by minute, up, up. So right there, boom, pause. 5 a.m., right? 5:55 a.m. is when the sun rises this 4th of July. All right. Now, the location for this is our current location, Southeast Michigan. Okay. I have no idea what Walden Cove is, by the way, but apparently I'm near it. All right. Anyways, it rises at 5:55, right? Boom. And then what we're going to do is we're going to go hour by hour and we're going to look at how high it is. And we're going to mark it on our maps. Okay. That's it. So this is Farmington Hills. Okay. All right. Thank you all.